When we talk about model monitoring, there are two important concepts that one need to remember. One is concept drift and second is data drift. Now coming to concept drift is basically when the statistical properties of your model output, or more specifically the value you are trying to predict, changes over time. Now, it can change due to an business scenario change. The business itself is completely changing. You are acquiring a company. It can be anything. Or it can change because the training data that you use to train the model does not represent the entire population that basically is coming through during the prediction. Now, let me give you an example of concept drift. Take the initial telecom industry. Basically, the number you are using is bound to the service provider. It can be AT&T, it can be T-Mobile, it can be anything. If you're in another country, it can be Jio, Airtel. It was pretty much bound to your service provider. But later, after a few years, they introduced something called number portability. Now, number portability is basically you can take the same number, but you can go to a different service provider. And think of the time like when there was no number portability and you developed an churn prediction model, a customer churn prediction model. Most of the time, customer do not want to change their number. The number is with everyone and they want to keep the number. So basically, even though they are not happy with the service, they would stick on to that particular service provider. And you have a model that has been predicting customer churn pretty well. But all of a sudden, basically an number portability concept was introduced and a lot of customer took opportunity and moved from one carrier to another. So basically what you are seeing here is your prediction is no longer valid based on the underlying assumption. There is a new business scenario that has come into existence and that can cause a higher number of churn. So basically your model has to be recalibrated, and since you will not have lot of data set for some time to recalibrate it, your model has to take that into account or maybe substitute it with more like a probabilistic model or more like a deterministic model where customers can be incentivized to not port. That is one scenario. The second scenario is in the credit card industry. In earlier stages, basically the credit card used to work based on a magnetic tape. There's a magnetic tape in the back which you go and slide your credit card. Now the problem with the magnetic tape is anybody can skim your credit card. So basically, if you go to merchant, an employee can go and use a skimmer to skim the credit card, and that's the exact reason the chip was introduced in a card which cannot be skimmed. Basically, you insert the chip these days, and that has reduced the fraud substantially. Now think if you have developed a model in an pre-magnetic tape card era and you moved into an EMV world, your model is no longer having the same predictive power. But one thing, if you notice what happened after the introducing of EMV, lot of fraud that was happening on the point of sales got shifted into online. So basically in online, you don't use your chip anyway. What happened, like people started stealing the credit card and then selling the credit card in the gray market so others can buy it and use it for fraud. So basically these are some of the scenarios where your underlying model assumptions can change and you may have to recalibrate the model. And this is one scenario where a continuous monitoring of your model is required. In some cases, even if you continuously monitor, it may not be alert or something like that. So there are some techniques which we'll talk in a later stage. But this is concept drift. The second is data drift. So data drift is your model is not drifting, or your model has drifted. It can be drifted due to a particular feature that is used in the particular model. Or your model is fine, but the data can drift by itself, but your model is using it for prediction and that particular model prediction might not be accurate at all. So there are multiple scenarios over here. Now data can drift because of any data quality issue also. So your upstream that is sending the data might have changed something in the system and that might have caused the data to come wrong to downstream system, and it can be your model as well. Or you are depending on the particular data that is coming from a third party vendor, and the third party vendor might have changed some logic in the data, and when you're getting the data, basically you are kind of seeing a completely different data set, and your model is trying to predict based on that, where the model can get drifted. The other scenario is your business scenario has again changed, because of which a new additional data element has been introduced, or an additional category has been introduced. Say you are having one of the categorical variables as product, and you have basically the line some kind of a product category, and a new product category has been introduced in your enterprise. Then basically that the model has not seen. So in this scenario also, you may have to recalibrate and retrain the model so that the model is predicting on the new instances. So in the next video, we will see techniques to handle this concept drift and data drift. You will see some of the techniques on how this can be detected and what is the process for recalibrating and further deploying it in the system. Thank you.